talk about something called domain and range today. Keep in mind, you don't have to write this down unless you just want to in your journal. We can just watch. Finite means we have a fixed or accountable number of elements, meaning if, for example, when we solved the equation, sometimes we had one solution, right? So that is a finite set. An infinite set has an unlimited number of solutions. So for example, when we solve an inequality and we draw that arrow, we have a lot of different answers we could have. So I want to practice with you. We were finished up inequalities. I want you to look at some situations and how we would write an inequality, because that's going to lead into something called domain and range that we're going to do. So right here it says 21 reasons to keep the legal drinking age at 21. So in the United States, some countries are different than the United States, but in the United States, you cannot drink unless you are 21 years of age. So what would this look like if I'm using A for age and I'm comparing it to 21? What is my inequality symbol going to be? What does your age need to be compared to 21? Nate? Greater than or equal to. Do you agree with that? All right, so if I put that on a number line, open or closed, left or right? Right. Now, this is technically an infinite set. We do know that this is not going to go to positive infinity, right? You cannot be positive infinity years old. So hopefully you do live a nice long life, and after the age of 21, you can have a beverage should you feel the need to, but you are not 21, so you cannot until that age. So maybe, for example, my grandmother was 94, right? That is still an infinite number of sets, right? And it is still going to be a line. It is still continuous because you can be 21 years old and 1 day and 3 seconds. Okay? Right? It's going to include, it's not just going to be discrete where we did the dots on the push-ups and the sit-ups. All right? We'll look at that later on. Anyone want to add to that? All right. Okay, this one's a little different. This is kind of where we're going today. The minimum speed is 55. What does that look like? How are we going to write an inequality? What's less than? What's less than 55? What letter do you want to use? S. Okay, make your S look like an S and not a 5, right? That's the trick. So S needs to be less than 55, really? And the minimum is 55. So greater than or equal to. Good catch, good catch. So if that is the minimum, that is the smallest. So you can go exactly 55 or more. Yes? What about this one? The maximum speed limit is 75. What does that look like? S compared to 75 is what? That one is less than or equal to. So you can go between 55 and 75. You do see minimum speed limit signs on most of the major highways. You do not want to go lower than the minimum speed limit because you can get a ticket because that is a hindrance. Now, here's what we're going to do today. Do you realize, so I want to show this as one inequality. We have something called compound inequalities. So, you know how you compound words? Classroom in English? Okay, we have something called compound inequality. So I want to take and I want to put these together. So I want to show you something. And remember how we talked about you can flip-flop an inequality the other day? I'm going to flip-flop this one. I'm going to do that less than that Aiden was talking about. I want you to look at this. 55 is less than or equal to S, and S is less than or equal to 75. Let's write that together. 55 is less than or equal to S is less than or equal to 75. Does this say the same as these two? Yes, this says we have to be greater than or equal to 55, but less than or equal to 75. Can I write that? Is that not what this compound inequality says? So essentially what I did was I took this one and I brought it down and overlapped the S, and now I have this. So this says 55 is the lowest that I can go and 75 is the highest I can go. Do you understand that? Okay. Ooh, what does this look like graphed? Here's 55. Here's 75. Do you remember when we first did inequalities and we had that question that said x is less than or equal to -3 and x is greater than or equal to -3? And you had a circle in the middle and your arrows went both ways? Let's think about this. What kind of circle do I have for 55? Close. What kind of circle do I have for 75? Close. What direction is my 55 going to go? To the right. What is it going to go on this one? To the left. So guess what? All of these speeds would make that inequality true. Okay, so do you see how that looks different than a regular inequality, right? It's a compound. Yeah, it would just be here. But it's not going to go past is what I'm saying. It's going to stop. All right? You're going to love this one. I know you're super excited about it.
Oh, I'm so sad.
160 inches? It's like over 13 feet. Some of us are vertically challenged. In this case, all of us are vertically challenged. I don't know anyone over 13 feet tall. I am not making... So, height. How does your height compare to 160 here? Greater than, thank you. All right, so is that an open or a closed circle? Open, arrow to the right. Okay, so you feel good about that? All right, so here's what we're going to do. I need you to take out your paper from the table. And if you have a highlighter, I need you to take that out because that is going to be super fun today. 13 and 4 inches. All right, so let's get prepared. All right, so domain and range was introduced to you in our function foldable, and we did learn that domain is going to represent your x values, and range is going to represent your y values. Okay, and that is going to be super duper important. Also, we briefly discussed when we were talking about inequalities, continuous versus discrete. So continuous means that you can take your pencil and trace the whole graph without picking it up. We also talked about discrete, meaning when we talked about sit-ups and push-ups and you couldn't have a half of one. So that is going to play a role today. The first thing I want you to do, we're going to talk about something called function windows. So I want to only focus on where this graph is. So I want you to take your highlighter or your color pencil or whatever you're using. And I want you to draw a window around your graph because that is the only part we need to focus on. Okay? So we are going to write what we call a domain and a range for this. Remember, domain is your x values and range is your y values. I forgot the U. I teach math. All right. I do want you to notice that this is
Please pardon this interruption. So Evangeline, Markham, and Yara of Nolchabar, please report to
continuous. So that means that we need to make sure.
Markham and Yara of Nolchabar, please report to the gym.
So that means that we do need to make sure that we are representing all of the numbers in between our high and our low x values. Now we are going to write these as a compound inequality, and there is a method to this. They're very easy steps, so I just want you to try to process them. We are going to start with our lowest x value because this is domain. Our variable will be x, and then we have our highest x value. So let's start there. What is your lowest x value? X's, remember, are across, so you're looking at your side frames. What is this? -3. What is this one? To what? What's your highest one? 4. Now, I want you to realize that means all of our x values are between -3 and +4. So we need to use inequalities to show that continuation between those numbers, kind of like when we colored all the way in between on our number line. Now, circles matter in inequalities. I want you to look at your -3. What kind of circle is this? Open. So is that equal to or not or equal to? that is not or equal to, and it is our lowest one, so negative 3 is the lowest of all of the x's, so negative 3 is less than x. What about your 4? What kind of circle is that? Closed. So is that or equal to or not? It is, and it is our highest, so let's see how we read this. This says negative 3 is less than all of the x's, and x is less than or equal to 4. Okay, so the pattern is this. Low. These are always going to be less than. It just depends on if it's less than or equal to or not. And this is always your high. Maddie. No. All right, so let's look at it for the range. So your range is up and down. So again, lowest, we know this is going to be a less than of some sort. We'll figure out which one. Range is y, less than high. What is our lowest y value here? Negative 1. Now, we'll come back to the inequalities in a minute. What is your highest? Notice that this graph is touching at what? 4. Do you see that? So we are including 4. So now you need to decide what kind of symbol. So look at this negative 1. There is an open circle and a closed circle. Which one do you think is going to win? The closed circle, right? Because this is not including negative 1, but this one is. So closed will always win. So negative 1 is less than or equal to y. What about the 4? Is the graph touching the 4? Yes. So it is or equal to. Okay? If it's touching it, it's including it, which means it's or equal to. It's inclusive. Okay? You feel okay about that? That's okay. We're going to do some more. What is different about C? Yes. It has arrows. What do the arrows mean? It is going to keep going forever and ever and ever. So the only part of the window you can draw on C is here. Now, let's think about this. If the arrows are going to go on and on and on for our x values forever and ever and ever, what is that called? Infinite. Right? We're not going to write it in our format. We're not going to write negative infinity less than or equal to x less than or equal to positive infinity. We have another word for that. Does anybody remember it? Yes. All real numbers. This is the symbol. It is an R with 2 lines. All real numbers. Okay? But let's look at the range. Do we have a lowest y value? We've got arrows, so they're going forever and ever and ever out left and right, but also down. So does it stop? No. What is that? It's not all real numbers this time. This is technically negative infinity. Now, watch, I wrote it really, really light because we don't actually need to write it. Y, we need to write the y. Look at our top. What's the top? 2. Is it including 2? Yes. So what are we going to write? Less than or equal to. So all you really need to write is this. If you say all of the y's are less than or equal to 2, then you're implying that it's going to go to negative infinity. Okay? If you want to draw the infinity symbol, that's fine, but you're not going to see it that way. All right? So we're good on B, and we're good on C. So I'm going to have you try D.